Welcome. My name is Johannes Kebeck, and I'm Virtual Earth Technology Specialist. I'm a pretty rare species. There's only one of my kind outside the US, so I'm looking after customers and partners all over Europe and in the Asia-Pacific region as well, including Australia. And my part is not only to do these kind of presentations and workshops, but also technical trainings. Sometimes I work in the proof of concept and these kind of engagements. That is my daily business. I have about 12-year experience in the GIS market, and so it's really an exciting step for me. I joined the Virtual Earth business unit a little bit more than 2 years ago, so that coincided with the launch of Virtual Earth itself, and that was, I can say I'm really with this technology since it was born to the last release, which happened 2 weeks ago. So to give me an idea about your background and your interests, maybe you can tell me who of you has seen Virtual Earth before? All right. So who of you has worked with Virtual Earth before? Okay, a lot less. And who of you has worked with the last version, version 6 of Virtual Earth? So about a dozen. Okay, so what is the kind of background that you have? Who of you are GIS specialists? Oh, quite a few. That's interesting. So that gives me a rough idea. And the rest of you, how many of you are web developers? Designers? Okay. Okay, that gives me a little bit of an impression how many people are here with a GIS background, how many have seen Virtual Earth, how many have worked with it, and that will me allow to adjust the complexity of the stuff that I'm about to present to the audience. All right. So within the next hour and 50 minutes, I'm going to talk about the history and the motivation very briefly, and then I come to the new features that we introduced in version 6. That will also be a quite quick overview, and then I get into getting started with coding with Virtual Earth, how easy it can be, and move very quickly to the more complex stuff. So how do we integrate with GIS systems? How do we overlay data from your own database? How do you create your own imagery that you want to overlay on top of Virtual Earth, and so on. And finally, I will have a brief overview about how we integrate Virtual Earth with the next version of our SQL Server. You probably heard that SQL Server 2008 will have a spatial engine. Finally, we're there, and we have a spatial-enabled database. And of course, that is a natural fit to integrate these data from our database directly with Virtual Earth. And I will give you also an overview about a few more things that are coming within the next months or in the midterm in Virtual Earth. So let's start right away with the motivation for that. So we can really see that geospatial information has now reached the mainstream. Particularly, the analysts have been talking about geotechnology becoming more important, at least for the last 10 years. But there are a couple of things which contributed to this success of geospatial information in this mainstream market in the last couple of years. It was foreseen by the interested people who are interested in geospatial data for quite a while. And it is not really surprising that the Department of Labor discovered the 3 most important technologies for coming years as geotechnology, nanotechnology, and biotechnology, and really geotechnology ranking first in that. You can imagine all these kind of analyses, particularly in the US, with Homeland Security, that has all a location relevance, and that is all about integration of location data in various intelligence systems analyzer systems, maybe even mining, spatial mining systems. But, well, when we thought about what we're going to do in this market, we had already quite a background in this area. Microsoft is in geospatial data about 12 years now. And we started in 1995 with some desktop products, and then we moved to the web in 2000 with the MapPoint web service. So we are not that new in this geospatial area. But of course, we followed all these developments, and we were interested in why and how the analysts believe that geotechnology becomes more important, what is the market behind that, and so on. Well, and it is quite obvious that with this more importance of geotechnology, we also have to make it more accessible and more easier to develop around it. So this coincided with a couple of enabling technologies in the web. So Web 2 is one of these buzzwords that everybody is talking about. So we have a richer experience in the web, and that must also have some influence on mapping platforms, on visualizing geographical data on the web. So one of the enabling technologies is AJAX, asynchronous JavaScript and XML, which allows us to do these partial page updates. We don't have to do a server callback every time that we want to refresh a map, that we want to move the map slightly to the left or to the right. That was what we had to do with the MapPoint web service, a purely standard compliant SOAP web service, a request and a response. That was good for that time. It is still good. But users want to have a richer experience in the web, so AJAX integration is a natural fit for that. The other thing is, of course, we need to have richer content than we had before. MapPoint web service was roadmaps only, and Virtual Earth provides now imagery of various types and even 3D content in a very performant way, even over the internet and web applications that we have today. So that is a huge leap in terms of what we can provide to the front end and what we can provide to the consumers. So when we were launching this project, that was really with very high attention. And that is a story I really like a lot. We do these proposals. We worked on one of the proposals for Bill Gates Think Weeks. And I'm not sure if you have heard about it, but Bill Gates retreats twice a year to a very quiet place, no phones, no emails, but only 100 pre-selected proposals from all over the company, how Microsoft should develop in a strategic way, technological way, of course. He's not so much interested in the business and financial work that is necessary, of course. He's more interested in technology. And we said, hey, we believe that we have the good idea for the next generation mapping platform. We have an idea about enhancing the content, about enabling the user with a richer experience. And here is the business case. And the business case was not just more enterprise applications, sleeker store locators or tracking applications. That is, of course, a huge amount of the mapping applications that we see today. But we also found out that, or actually the analysts found out, and we picked it up, that there is a new market emerging, a market for location-based advertisement. And that is quite interesting. If you consider that 70 to 80% of all searches on the internet have some kind of location relevance, that gives you an idea that there is, of course, also a huge market for those who want to provide advertisement. 70 to 80%. Now imagine, if you want to look for a plumber or for a dentist or for a Chinese restaurant, then you don't want a Chinese restaurant in China. You want to have the Chinese restaurant just around the corner, maybe somewhere here next to your hotel. Yes? So we need to make it possible that we narrow down the searches on the internet with a relevance, a location relevance that is relevant for you and then also relevant for the advertiser. The small hotel around the corner is not interested in providing a huge amount of money for global advertisement. It wants only to pay per click when you look up a hotel just in that area where they have some rooms available. Yeah? Not just if you are looking for the Hilton, that may be another thing, but the hotelier around the corner, he only wants to have the result when you are looking here for Barcelona, not when you are looking in Madrid. So if we can make that happen, if we can make the internet search a local search, if we can narrow it down, and if we can also provide local content, the local knowledge that people have for their hometowns, for their areas, and make that accessible for the whole world, if we can make that happen, we can have a good start in this location-based advertisement market. And this market is estimated to grow to a volume of about $50 billion a year. And if you consider that, that's a huge amount of money. The analysts also believed that we would probably be able, if we do well, to get a market share of around 20%. And if that is true again, then we are almost in the range of what we make revenue with the Office product. So that was a strong motivation. Bill Gates said, well, guys, that sounds interesting, go ahead. And I want to have a quarterly update. So he is indeed still our executive sponsor of the Virtual Earth project. And he is still influencing the development of the platform. It is not the niche technology anymore, as you might have said about MapPoint Web Service. It is now really in the major focus of Microsoft and their senior executives. Right. So, of course, when we started this project, we were very enthusiastic. We had a couple of experience already. You know about, I talked about the MapPoint Web Service on the web. I talked about the other experiences that we had with geospatial data. We also had, with imagery, some experience. You might have heard about the TerraMap server. That was something that we have set up a couple of years ago with SQL Server 2000 to prove the concept of very large databases. So we had quite some experience in that space. But even the TerraMap server was just providing one type of imagery, vertical aerial images, and just for the US. Now we are going a couple of steps further. We are providing, or we are aiming to provide content for the whole world. And we have different type of imagery, so the amount of data is a lot bigger. So currently we have some petabyte of data in our databases that we make available. When we launch a new city in 3D, each of these cities adds 100 terabyte to our infrastructure. We have monthly updates of data in the range of 30 to 50 terabyte. And you can imagine if we are talking about these amounts of data, then we are talking about huge server farms as well. We have only in the United States 1,500 servers in 2 hot data centers, and we have other data centers in Japan, India, and China. So there is a huge infrastructure, and that required a huge investment, of course, in data, in hardware, and in knowledge. And to be honest, not all that knowledge was in-house. Yeah? And you can imagine about the same time when we started, Google started as well. So it is not just to have a great product, you need to have the great product also in time. Yeah? If you miss the train, then you just be sorry. Yeah? So there is no medal for the second place in this case. So in that case, you can consider either to sit back, do the development, learn a little bit, and then come out with a great product, or to buy some external knowledge in. And we did that. We bought a company called Vexcel. Vexcel is very well known, particularly in this photogrammetry and 3D space. And they have about 150 employees, and 100 of them are PhDs. And they have significant experience, not just with the data acquisition, what you see here, satellite ground stations, large-scale digital aerial cameras, but also with the processing of these data. Yeah? They are able to take their stereo aerial images that have been created with the Vexcel UltraCam and extract 3D models just from these images. Yeah? These images have been taken with a overlapping of about 80%. So each location has 4, 5, or even more images which cover this particular area. So we can take that together with some digital terrain models and extract the 3D imagery of these, or the 3D models of these buildings in that area. And we can also extract the textures of these buildings and apply it in a, well, in the meantime, fully automated process. That was the main reason why we needed Vexcel, the knowledge to help us work on these challenges that we were facing. So in the meantime, I said this pipeline is fully automated. And that means that after the first year where we had only 120 cities launched, in the next year until the end of our fiscal year, which is, as you know, in June, we will have another 500 cities in 3D with full textured models, and that will be mainly in Europe. So you see here we have this data acquisition and processing capabilities now within our company, but in the end, everything comes down to the presentation. Everything is there to bring the best experience. That is our goal. We may not always get it, but we always try to be the best in class, and we want to have that in the presentation layer. That is our goal that we want to achieve. So we do a great deal about confusing ourselves sometimes, and certainly about our clients and partners with branding. Yeah? You may have heard about Virtual Earth, the Virtual Earth platform, MapPoint, MapPoint Web Service, MapPoint North America, MapPoint Location Server, Windows Live Local, Windows Live Maps, Live Search Maps. So there are so many names, and we changed, unfortunately, these names much too often. So let me try to bring, shed a little bit of light in this confusion. The Virtual Earth platform is really the location platform that powers our consumer offering, which is now Live Search Maps. And Live Search Maps was formerly known as Windows Live Maps, and before that as Windows Live Local. So it changed the name. But Windows Live or Live Search Maps is really the consumer offering. Everybody can access it for free over the internet. There is a couple of features which are only available in this platform. And the technology behind it, that is the Virtual Earth platform. In this platform, we have two major services. One of those is Virtual Earth, and Virtual Earth can be, under certain circumstances, for free. It is for free if you don't exceed 100,000 transactions a day, if the application that you are about to develop is free accessible on the internet. So if you don't have any requirements for logins, or if it is not on the intranet, if everybody can access it, then it can be for free. If you don't need a service level agreement, if you don't need support, and if you don't mind that sooner or later advertisement will be on this map. Yeah? So the idea behind all these free offerings is the refinancing through advertisement. On the other side, we have the enterprise platform. That enterprise platform will get rid of all these downsides that I just mentioned. You have support, you have no advertisement. I mean, imagine that you are working for FedEx, for instance, one of our clients, and on this map would show up advertisement for DHL. That would be quite embarrassing for FedEx. Yeah? Or let's assume that you have a strategic business critical application. BP, British Petroleum, for instance, has a hurricane management system based on Virtual Earth. And if there is a hurricane, and just in that case, the system would be down, that is a disaster. Yeah? That cannot happen. You need to have the highest service level agreement and support for these kind of incidents. So in that case, they are very happy to take the enterprise platform, and they not only have Virtual Earth on the one side, but part of that is then also the MapPoint Web Service, which adds additional functionality and other APIs. So let's have a look at the two columns. In Virtual Earth itself, we have an AJAX control. I mentioned before that is asynchronous Java and XML, and that has many advantages in terms of rich experience. You load it directly from the Microsoft servers. You load the imagery from the Microsoft servers, and the content that you want to put on top of it that comes from your own servers or from web map servers or whatever you want to overlay there. But the maps always come from us. So you distribute the load as well, and you make it much faster. That's good. The experience is good. The content is great. But Ajax has also a couple of downsides. One of these downsides is that Ajax is based on JavaScript and XML, of course. And that means that not any platform will allow you to use this kind of API. If you work in a high security environment, let's say in intelligence services, sometimes in banking and finance, JavaScript will be blocked at the firewall. If that happens, you cannot work in a supported way with the virtual earth control anymore. It always requires JavaScript to be enabled. You could, on the other side, if you have internet connection at all, still set up a SOAP call, a web service call, because there is no any kind of active content or script language in this SOAP API, unless you code it in your own application. So that would go through all these firewalls without any problems. Well, Ajax JavaScript also have the downside that they are not fully standardized. Yeah? So if you try to adjust the size of the map to the size of the browser window, for instance, the JavaScript command that you need to determine the height and the width of the browser window is a different one if you do that in Firefox than if you do it in Internet Explorer, and it's then different if you work with Safari. So in that case, developers always have to look at what kind of browsers they want to support. And well, we started, of course, with the Internet Explorer, version 6 and higher. And the next biggest one on the market is the Firefox. As you probably know, statistics vary between 30 and 40%, somewhere in between. Depends also on the clientele, is the market share of Firefox. So that was a natural fit. We needed to have support for Firefox as well, and we do that since version 1.5. Everything above that is supported. Since 2 weeks now, we also support the Safari browser in version 2.0 and higher. And with these 3 browsers, we probably have around 97% of the browsers on the internet, particularly if you consider that the Firefox is based on the Gecko engine, and there are a couple of other browsers which use this Gecko engine as well, like the Netscape, like Mozilla. So if we take these browsers which are not officially supported but still work, also into consideration, then we are surely at around 97% of all browsers. Well, on the other side, the MapPoint web service, SOAP, and that requires basically an internet connection and XML support. That means that you can use any coding language, and you can also use any browser. Any limitation comes just from your coding that you do yourself. Interesting, by the way, we provide active support not just for the .NET platform, but also for Java, PHP, and Perl. The content is clearly richer in Virtual Earth. We have the roadmaps. Currently, we have major roads worldwide, so we can calculate a route from here directly to Kinshasa. But that is only the major road network. Yeah? Detailed road coverage is currently available in 68 countries, and that includes all over Europe. We have now, Southern and Central Europe and Northern Europe, not Eastern Europe. We are starting to get coverage in these areas as well. Poland, Czech Republic, Slovakia are recently added. But we will, of course, increase our coverage in the other markets as well. In Virtual Earth, we also have imagery. We have vertical and oblique aerial images, and we have 3D models, and we will have a look at that a little bit later. One of the downsides that we currently have in Virtual Earth is the lack of language support. We only have English, and in Japan we have also Japanese. With the very next version of Virtual Earth, which is not just a major release, it is a quick fix by the end of November, we will have a first support for 13 languages, the 13 languages that we have in MapPoint Web Service for geocoding and for driving directions. That does not yet solve the issue with the labels on the map, and that is kind of a problem for us because unlike MapPoint Web Service, where we render the maps ad hoc, we define a scale and the size of the map, and then it is rendered at runtime. In Virtual Earth, we did a different approach. We said we pre-render these maps and images and create tiles of a size of 256 times 256 pixels, which are then stitched together in the map control on the client browser and cached in the local browser cache for up to 7 days. That has many advantages. Performance advantages on the one side, if you cache these data, of course. Yeah. On the other side, we can spend more time on the quality because during this pre-processing of the tiles, we also apply anti-aliasing filters, which means that the maps look a lot smoother than it does in MapPoint Web Service, where without anti-aliasing, we have a little bit pixelized labels and roads. So we are currently working on this localized labels. I don't have a firm time for localized labels yet, but I would say within the next half year is very likely that we will have sorted that out. Right. MapPoint Web Service has a couple of advantages through the API, and there are a number of reasons why even when I have Virtual Earth in the front end, I might still want to use MapPoint Web Service in the business layer for a couple of functions, analysis functions, and queries. Geocoding in multiple languages was one of these reasons. If we want to calculate a route, for instance, and bypass, avoid highways, ferries, these kind of things, that is something that we can do in MapPoint Web Service today, but we can't do it in Virtual Earth yet. I will give you another example a little bit later, but I would say that there is just one reason why I would want to bring MapPoint Web Service still to the presentation layer, and that is this particular map style. Yeah? If you want to have a map provided for very small devices, or if you want to print it out, then we allow this type of line drive map style. This is a map which is out of scale, but it has the direction, the distance, and the name of the roads and the turn from your start point to the end point. So it removes the complexity of the map, and it creates a kind of sketch as if someone would call you and describes the route, how you get to his place, and you make a couple of lines on a piece of paper. This is more or less the outcome. So a number of our clients do this. They say, okay, Virtual Earth is great, but as soon as it comes to printing, we want to offer our users a choice. They have overview maps and turn-by-turn directions, of course, yeah, so that we have segment maps for this tour. But as an option, they also provide the printout with these line drive maps. Another really big advantage is the platform that we can use with the MapPoint Web Service. And what you see here is an example where I created an assembly in SQL Server 2005 to add geocoding capabilities directly within the database. So this is still a hot topic, and in SQL Server 2008 we will not have solved this issue. In SQL Server 2008 we have a lot of spatial functions, 76, but there is no geocoding in the database. So what we can do here is, let me switch to this platform. I have now a database table here And if I select this query, you see there is no latitude and longitude. It is just the address field. But I have loaded a function, a .NET function, which is supported in SQL Server since 2005, directly in the common language runtime. You see here that I have an assembly geocode, and I have a stored procedure which calls this assembly. And as soon as I execute this assembly, it calls out to the MapPoint web service. And now you see that it calculated the latitude and longitude and updated the table. Yeah? So this is for a lot of things of advantage. If you maintain address tables somewhere in the database, you can do that by a geocoded, enable it thus for use with the map. You can export a CSV or XML file and upload it to a geocoder. You can do a MapPoint web service call for each of those, or you can just put a trigger on this table and say whenever you update or insert a new record, then you do a call out to a MapPoint web service, take this address, calculate the latitude and longitude, and update the row. All right. But let's not talk too much about MapPoint web service and more about virtual Earth. You see here that when we launched virtual Earth with a certain type of imagery, the first launch was 2005 in July. We added bird's eye imagery in the US in a couple of regions in December 2005. And this year in May, we launched this oblique aerial images, the bird's eye view that you see here in Germany. We didn't have any ortho photos at that time, and we didn't have localization for the roads, no local labels, no local driving directions at that time. And you still see what the result of the survey was. They compared virtual Earth with a couple of other mapping platforms, and we won just because of this type of imagery. So that is not just the German phenomenon. If you'll see here, we have similar results in the US that we have been compared with a couple of other mapping platforms. Google is always there, of course. And to be honest, this is not the virtual Earth platform itself. What here was compared was live search maps. And as I mentioned before, there are some other features in live search maps that may not be accessible directly in virtual Earth. Well, but on the right-hand side, you see that our business customers are equally satisfied. And the reason for that is, number one, really that we have these unique type of images. So before, you see here an ortho image of the Transamerica building. And if you see that same building in an oblique angle, you see how much more information you can get out of it. And you can turn these images now around in 90-degree steps so that you can look to the north, east, south, and west at the same building. And that is because of a patented technology that has been developed by Pictometry. And Pictometry and their sub-licensees in Europe, it is a company called Blom. They sell us these data. And our goal is to have 80% of the populated area covered with this type of imagery. So at that point, let's have a quick look at what we added with the last release. And to do that, I will call my browser. We're looking here at our conference center. In this case, we have our roadmaps here. And you see, well, that is not too exciting. We don't even see exactly where the conference center is. So we can easily switch to an aerial view, which gives us then, in this case, just a satellite image. In most cases, we have aerial images which have been taken from a low-flying plane. And now here we overlay the road maps on top of the aerial image. This is what we call a hybrid map. But really exciting is if we now switch to these bird's eye images. Yeah, and we can zoom in a little bit closer. And now we see, okay, this is, well, some people would call it art. I don't know exactly what it is here in front of the building. And we can even move here around, see between the buildings. And of course, we can turn it in a way that we now look to the east side, that we look to the south side, and so on and so on. So this is a unique type of content. That is something that you can buy directly from Pictometry for a lot of money, but it is not available in other mapping platforms today. Right. That is not new, as I mentioned. What is new is that we have 3D now on top of bird's eye images now on top of 3D. So let's have a look at an impressive place, and I always like to show Manhattan because the skyline is so impressive. Let's go to Manhattan, switch to 3D, and close our sketchpad here. So we can navigate now around in this area. This is all streamed live over the internet. Yeah? There is nothing that I have locally on my machine. This is direct connection over the internet, not even our internal network. Everybody has the same experience when he accesses it. Well, not everybody. People who try to do that in the exhibition area will realize that the PCs there don't have a hardware acceleration in the graphics adapter, and that is something that you would want to have. Yeah? And quite frankly, if you don't have a broadband internet connection, it's not fun either. At least not in this quality, but we can enhance the quality even. Yeah? So in this case, I can say I want to overlay on top of these 3D models now our bird's eye imagery. And what happens now is that we load, who of you has heard about Photosynth? All right, so a few. Photosynth is the technology that is based on the Sea-Dragon engine and processes then imagery. And Photosynth is a project that is live in a technology preview. And this is also the technology that we use to overlay the bird's eye images on Virtual Earth 3D. So here you see on the right-hand side that is already good. Yeah, it is not as if this is just rubbish here, but it is imagery that we have from vertical aerial images. We have extracted the textures and applied them to our 3D models. On the left-hand side, you see how we did it with our bird's eye images, and you see this is now really photorealistic 3D experience. I don't think it can get much better nowadays. So this experience in 3D is really what I think awesome. So on the other side, if you do have a slow connection, or if you have special requirements, and I will come to that example a little bit later, you can just switch off the details, yeah, and with the Shift-D key, we just remove the textures, and with Shift-B, we remove the buildings, and now we can start and create our own buildings. Yeah? So the developer, the architect who wants to build a new warehouse, maybe here in this area, he can zoom in a little bit. And what we launched 2 weeks ago is now our first version of the 3D client. So let's take this building, and let's say I want to add a 3D model. So I open my collection, and here at this place, I want to build a new house. So in this case, it launches now our 3D client. If you don't have it installed, it will prompt you to install this 3D modeling tool. That is a tool, Virtual Earth 3D VIA. It has been developed together with a company, French company, Dassault Systems. And this is a free version. There will also be a professional version which allows import and export of these 3D models. But this version is now for free. And I always suggest take the time, if you do it for the very first time, and have a look at the video tutorials, because the navigation requires a little bit of practice. So I don't need that right now. Let's just have a look at this. And first of all, I adjust the grid line to the environment here. And once I have done that, I can start drawing my platform for the house. Yeah? So in this case, I don't do it for beauty now, but just for speed. I draw the basement, and then I can tilt it, apply some altitude to the building, And then I always want to change the perspective whenever I want to make changes. So in that, let's say I want to have a door frame. So it snaps in here, and then I can give that door frame a little bit of depth. And I can also draw a window. So in that case, I take this point. You see the magnet popping up, and I can then take that as a grid for the upper window here. And then I want to have the window as deep in as, come on, that was rubbish. So I want to have the window in as deep as the door. So I move over that, and it will take the same depth here. Right now, this is the first steps that I can do. I can also apply textures. So let's say I want to have a couple of pre-built textures here. So nowadays, most people build something in metal. So let's take here a metal texture, apply that to the doorway here. And on the side, just to show that this is possible as well, I define my new texture. And in that case, I want to take it from one of my images that I have locally available. And I fill that here. OK, that was the wrong image. So here is my texture. And you see the texture is not filling this. So I can just drag this in a way that it fills at least in the vertical direction. And now I can publish my data to Virtual Earth. This will be uploaded now into a Virtual Earth collection. I call that my test building. And it will be stored in the collection 07-1105. And I publish it now. And once this is done, we will see it popping up in Virtual Earth as well. Come on. Model has been published. And once we are here in Virtual Earth, we see the first block popping up. So here we applied the texture. And if we go to the side, we applied our own image. And you see that is an easy way. I don't think this building will win a prize, but nevertheless, it was just in a few mouse clicks the ability to overlay these data on top of Virtual Earth. And in the second part of my presentation, I will show you how we take these models and integrate it now in our own applications. So these are probably the two most visual experiences that we have in the new version 6. The 3D with bird's eye on top of it, and creating our own 3D models. But there is also a great new feature which allows us to explore collections. And that means that we can really search for any content that is somewhere on the web or that someone has provided here for this particular region. So as I move the map around, it will retrieve the new boundaries of the map and see what other people have published with this location reference. So apparently, many people are excited about this battery park here. But if we zoom out down a little bit lower, we will find there is also Inside Man, a movie that is coming here or whatever. Yeah, so lots of information, local content that people from this area or people who travel to this area have published. They have published it either as a Virtual Earth collection, or what we can do in the meantime, we also crawl and allow to import KML and KMZ files, so we can leverage all these, well, Google says 500 million KML files are there somewhere out in the web, and they are now searchable through Virtual Earth. Other formats that we can import into our collections and search are GPX, that is the XML format for GPS receivers, and we also support GeoRSS, of course. So this is probably a very nice way to make the local, or to discover the local knowledge from all over the world. We also introduced a new feature which is called the 3D tour. And let me switch back to 3D to demonstrate that. And close this here. Now I open another collection. Let's take my, come on, my collections, and I want to look at the London bus tour. And if I want to run this tour now in 3D, you will see that it loops through all the points in these collections, and it will show all the images that I defined to these points. And I can also, from the pop-up, if I create new points on the map, if I add that to my collection, I can define the animation that I want to have. So I capture the view from which I want to look at that building, and I can also capture any kind of animation, like fly around in a clockwise or anti-clockwise. And you see here, I have a button which allows me to record this overflight as well, and that will create a WMV file, which is then stored locally on your hard drive. So this is more or less the flight path that I defined. Enough for now. So let's stop that. Another feature that came new is one-click driving directions. So if I want to do something like, I want to find out seafood near Seattle, this will bring me now to the other part of the world, and it will pop up if I don't misspell it, the search results. And in this case, you see, I can see reviews of this. I can directly connect my mobile phone or my phone to this reception here and reserve a table for us. I can see what other people think about this place. That was not so new, but new is that we have one-click driving directions. Most people know how they get to Seattle, and they just don't know the directions for the last mile. So in this case, we can just select I'm coming from the north, and I'm coming then down the Interstate 5, and here are the last directions, the last turns that I need to do. So with just a couple of mouse clicks, I come to this view. All right. At this point, I'm going to close this and go back to my presentation. Other gadgets which are available for free are a mobile client. So this is wls.live.com. If you point your mobile browser to this, this will download a mobile application that installs not just on Windows mobile phones, but on other platforms as well. And we also have a free plugin for Outlook. This plugin calculates driving directions to your next meeting and blocks you also for the drive time. And then you can have the driving directions and the imagery that you select there, or the route description, inserted into your appointment and have it offline available directly from Outlook. So if we want to get started with the development, then we don't want to do this right now. But here we have the getting started. This is now the part which is probably more interesting for the coder. And let me give you the easiest way to get started first. The easiest way is really PopFly. And I think those of you who have been in the keynote speech, they have heard about that. Many others will have seen PopFly as well. So I can sign in here to my PopFly account. And in this case, I will not do a Warcraft demo. Like on the keynote speech, I will use Virtual Earth to create my own mashup. I'm always amazed how Bill Gates has looked once when he was young. All right, so here we see we have a couple of functional blocks. This is a Silverlight application, and I can select here one of these functional blocks, in that case Virtual Earth, and just drag and drop it to the canvas. Yeah? And if I'm searching for something else, let's say I want to have travel information, I take a block that I created myself, drag it to that canvas as well, and I can just connect these two blocks and define the relationship between the information which are being output by my block and the information which are being consumed by this virtual Earth block. So here I have the latitude, the longitude, particular icon, and then I have a title which will then take the traffic information. Now, if I want to have particular real-time traffic information, then it doesn't make sense that I only have this information once. I want to have it refreshed every 5 minutes. So I select the timer, connect that to my application here, and set it to 300 seconds or 5 minutes. And now I'm already done. I have a real-time traffic application, real-time traffic in this case for the UK, based on BBC Travel, which is an XML feed. In the background, this XML feed is being passed into an GeoRSS and overlaid on top of virtual Earth. So since traffic in the UK is always a chaos, there's a lot of traffic incidences. You will see that in a second. And also, PopFly is just beta yet. So we have to forgive a little bit with this designer for the performance. But you see now, these are the traffic incidences. Of course, we can narrow that down by area as well. And we have different symbols. The red ones mark a road closure, and the rest is just slow traffic that we have in this area. And this would refresh now every 5 seconds. Now, you have seen I just connected these functional blocks. That is what a business user can do. Yeah? I like the idea of really separating the coding from the process modeling. Yeah? Look at this mashup creator just as modeling a process. So if I go back, I can save this now. I can mesh it out as a web page, or I can directly integrate it into Windows Live Spaces. Yeah? And then it's available to the whole public, or I can just keep it for myself and only I look at it. On the other side, you see, beside this process modeling, there's also something how I can define these blocks. We have heard yesterday that there is a plugin, no, it was Monday on the keynote speech, that there is a plugin for Visual Studio, which allows us to define these blocks. But there's also another way. I can create one of these blocks directly here through this web application. And you will see now how they are being built. Basically, it is an XML manifest and a JavaScript. Here we have the XML manifest. Here we have the JavaScript. Now, I don't know what the syntax for that is. Yeah? And I really, I'm one of these guys who never reads the manual. He starts doing it with his hands first, and only if he got stuck, then he looks up the documentation. So what I can do here is, I can just see if someone has done anything about travel information. Aha. And if so, I can use the case tool, copy and steal everything, and just rip the complete block. Yeah? So you see here that the complete XML manifest and the JavaScript has been ripped from this block and is now available in my block. I can modify or extend it. I can save it and publish it again, yeah, under another name and make it available to the public, or just keep it for myself again. Well, this is certainly a very nice and easy way to get started, but sooner or later you may want to have something in your intranet, or you want to do some serious coding, overlaying and integrating it with other GIS systems, for instance, or your database. And that is where it makes sense to have a look at the API itself. And the best way to do that is really to have a look at this interactive SDK to get started. This interactive SDK shows you on the left-hand side, let me increase that a little bit, on the left-hand side, a couple of methods that we can call. Yeah? Frequently used functions, that is not exhaustive, but there are a lot of functions available here. So let's get started easy and say I want to have a specific map. And you see this is a real implementation of virtual Earth. This is not just a screenshot. This is hosted here in this div element. And as I flip through these tabulators here, I can select the complete source code. This is the source code, everything that is necessary to get started. And again, I can use the case tool, copy and steal everything, and insert it here in my web designer or web creation tool of choice. I like, of course, the Visual Studio. but the VI would even do as well. This is just pure HTML. There is nothing that needs to be compiled on this side. So let's see what happens here. We have a HTML document, and in the head, we integrate here the virtual Earth Ajax control. Basically, we point to a URL, which is somewhere on the web. Yeah? And you see, we have a version number. This is important to understand that really we have very clean releases. That is not like some of our competitors. We have partners who came to us because some of our competitors really bring in breaking changes within the same version number of the API. And that is, of course, for an enterprise application unacceptable. If you have a breaking change and from now, from suddenly the application is not working anymore, that is nothing that you can use in a business critical application. Not even on your website you would tolerate that. So here we have clean releases. If we go back to version 5, for instance, we will see, if we render it now, that we have the old dashboard. It looks completely different. The data in the backend is the same, but the dashboard here is already different. So you see this is version 5. If we go to version 6, then we will see the new style that you have seen before. So even though there is an ASHX extension, it is just a JavaScript. It is an ASHX extension because this JavaScript is downloaded in 5 parallel streams. This is not just compression of the JavaScript, it is also parallel downloading, which enhances the performance quite a lot. So through the compression, we come down from a 600K JavaScript to 120K. And if we split that in parallel streams, the download of this 120K is really fast. So the size of the map is actually determined here in this div element. Yeah? And of course, I can make that dynamic, but right now, I just change it to 800 times 600. And you see when I load the map, when the body of the HTML document is loaded, we also execute a function, the onload event getMap is fired. And this function instantiates the virtual Earth map control in the map and executes the function load map. Here we center on a particular latitude and longitude. In this case, it is somewhere in Seattle. And we have a zoom level here as well. So if I change the zoom level to something higher, we can go up to 21. I select 17 now. Then I will have a closer look. And I can also change here the style. We have an R for road, A for aerial, H for hybrid, O for oblique. And then we have something here that is a little bit confusing. So right now, let's not bother and have a look at that a little bit later. So here you see we have now the new version. This map is bigger. We have a closer zoom level, but we are still at the same region. And now if I want to switch to bird's eye, everything already works. I can pan around. Yeah, so I have the full base functionality of Virtual Earth directly just by loading the map. Yeah? I didn't even need to write a single line of code for that myself. If I want to have some getting started geocoding, that is of course the way to determine the latitude and longitude for the center point in the first place. But if you just want to have a quick overview about restricted number of locations, then you can also use live search maps. And what you see here is, if I switch back to 2D mode, and let me select my collections and go to the collection here, I can share these collections now. And if I do that, send an email, it will create a tiny URL, and this tiny URL creates, contains all the information that I stored in this VE collection. So if I click on this, this is all that I need. It will open in anyone's browser all the shared information that I made available in this collection. And you see, this is now published in form of an RSS feed. Yeah? In fact, this is a geo RSS feed. And if we click on subscribe, we see that we can subscribe to this feed and store it on our Outlook or wherever, or in the browser. But we can also do something else. If I tune the Internet Explorer in a way that I don't want to have this reading view, this will directly give me the XML information. And in this XML, we see all the latitude and longitudes that I applied to this information. So let's say I'm looking at the convention center here. There is the latitude and longitude, and you see this is the simple specification according to georss.org. It is based on OpenGIS Consortium standards and implements GML, the geographic markup language in this case. So we have to say, to be honest, GeoRSS is not really standardized yet, and there are a couple of attempts to have well, these location tags in various formats. So we have the simple specification, and we also support the WorldKit. So let me just take the latitude and longitude and bring it into my application here. And of course, I need to separate it by a comma. And this will bring me now to our conference center. So easy going. I didn't even need to remember a lot of code in this case. But now let's get a little bit more complex. Let's close this for now. If I want to have more information about the method that I just used, I can just flip one more tabulator and I get the full reference. Yeah? So this will tell me that I didn't even use all the parameters. There was this false. Yeah? So here you see false. That was the parameter fixed, which means I can switch off the interactivity of the virtual Earth control, and I can also allow to hide the dashboard in that case. Yeah? I can also apply other parameters for the mode, so that I start in 2D or 3D mode. I can apply a parameter which hides the switch. So particularly in this case here, we have the 2D, 3D switch. That is the switch which will be hidden. Yeah, and here comes one interesting point. Virtual Earth 3D is using Direct 3D. And it is implemented in a browser plugin based on .NET Framework 2.0. So to make it work, we need to have the .NET Framework 2.0 installed on the machine. And we also use Direct 3D. And thus, we need to have the Windows imaging component installed as well. So that means the 3D mode of Virtual Earth will only work on the Windows platform, XP Service Pack 2, Vista, and Windows Server 2003. However, the 2D mode works on any platform. We have no restrictions with the platform, only with the browser for 2D mode. So what might be interesting is that you determine in your JavaScript what is the platform, the operating system that the client is using. And if it is Linux, then, for instance, hide this switch so that we avoid any error messages that pop up on the client when he tries to switch on 3D mode, which is not supported on his operating system. Yeah? So we can do all these conditional functions directly here in JavaScript. So another interesting thing is the tile buffer. Tile buffer, if you go to this map here in 2D mode, you will see, now let's take our application. And let's switch on the Internet Explorer developer toolbar and outline our images. Yeah? So you see here we have the tiles, 256 times 256 pixel each. And we have only those tiles which are needed to provide the current map image. We don't have any buffers around that, right? But what we can do is, we can set this parameter here. So in that case, let me see, in the Virtual Earth Interactive SDK, the mode, we leave that to 2D mode. We show the switch, so that is going to be a true. And we want to have the tile buffer, let's say, set to 1. This is a bug in the documentation. Default is not 1, it's 0, nil. And if we now show this tile buffer, outline images, you see that there is a ring of additional tiles buffered already in the background. Yeah? So we store the map view itself, and for faster panning, we have now an additional ring of tiles around it. But faster panning comes always with a price. Yeah? So if you have these data already stored in the local browser cache, it's good. Yeah? If you always look at the same regions, but as you browse around in the whole world, you probably prefer a faster loading. And faster loading means as few tiles as possible. So I would leave the default as 0. But in some cases, let's say a local authority, which is always interested just in this region of the city or in one city only, it might make sense that I cache already a major amount of tiles. All right, so let's put that back to 0. These are just initial steps. The interactive SDK allows you to do a lot more, and it also points to a couple of resources. So for those of us who have some experience with the Virtual Earth already, we probably want to have a downloadable version. This is what you see here. So we have the complete reference of Virtual Earth, all the objects, classes, methods, and events that we have here, and a quick overview about the changes in version 6. All right. So let's crack on and get some content onto Virtual Earth. And to do that, I open another application. And let's take this one. And here we see I have an ASPX page. This is basically an ASP.NET AJAX-enabled page. And we have in this page, oh, this is not the application I wanted to have. We have an accordion panel. This is here. In this accordion panel, we have individual shapes, for instance. We have collection layers. We have POIs from database, and so on and so on. And whenever I click one of these checkboxes that we have here, I fire an on-click event. And this on-click event will then execute a JavaScript which I have in a separate file. So in this case, let's say I want to add my points on top of Virtual Earth. Add shapes, this is the function. So I retrieve the latitude and longitude. The type of the shape that I have, that can be a pushpin, a line, or polygon. And I set then title, description, icon, and finally I add it to my layer. So this is relatively simple coding. And if I want to see what it does, I have now here, for instance, a traffic cam, which shows us real-time traffic in London Parliament Square. Yeah? So this is content which is available on the internet. And this is a traffic cam which is being updated every 5 minutes or 10 minutes. And we retrieve the latest information. So this is from today, 15:49 local time, so 16:49 our time. But this can be really any type of content. So if we go here and have a look at the Microsoft head office in London, this is the strange building here, I can put up a pushpin which loads additional content. So here I have a complete web page which is rendered within this pushpin pop-up. And you see here, this is HD View. MSR HD View is a web client which allows you to render huge images, very performant over the internet. It is even capable of rendering hundreds of megabytes in one picture. And if I show you one great example, Microsoft Exterminal, let's go to HD view. Here we have a couple of examples. And let's go to Seattle downtown. This is an image with 3.7 gigapixel, yeah? So that it's more than 100 megabyte big. And now look how fast I can navigate around and how close I can get with this information. Yeah? This is really surprising. It's still buffering. The data is loaded on Amazon S3 in this case. Very performant, very cheap, very great online storage, and good value for money. And you see how close we can get to this crane operator. We had the big overview about downtown Seattle, and we can get that close. And how is that done? Similar to virtual Earth. We cut the big image in pyramid levels and mosaic all of these pyramid levels so that we only retrieve those information which are relevant for that particular zoom level. Yeah? So let's go away from here and back to my sample application. I showed you that I was adding a 3D model to our Barcelona. No, that was in New York. But here I can now load these 3D models directly into virtual Earth. Of course, I have to be in 3D mode. And let's load a model now in Thames Valley Park. That is the Microsoft head office in the UK. And here we go. Takes a while, but eventually we get there. So this is a little bit crude still, but you can do pretty exciting things with these 3D modelers. And this is just one example what you can do. Also, you can connect directly to your database. And how do we do that? Well, if we want to connect to the database, we basically leverage a capability of virtual Earth, which allows us to retrieve the bounding box of the map view. So we can attach events to the map on pen, on end zoom, or on start pen, on start zoom. But in this case, whenever I finish to zoom the map, or whenever I finish to pen the map, I want to fire an event. And in the first step, it will retrieve the latitude and longitude of the bounding box. Virtual Earth has a function which allows us to take any pixel coordinate and transform this pixel coordinate into a latitude and longitude. And this is then a parameter that I can use for my geocoded information in my database. So I determine upper left and lower right corner, the bounding box, and I use that then in a query, an AJAX call to a web service. I build the URL, and as parameters in the URL, I have these bounding box. Now, this AJAX call calls a web service. And the web service will then, on behalf of the client, execute the SQL query, take the results, and create either JSON objects, that is probably one of the most performant ways, or directly in JavaScript or in GeoRSS feed, whatever you prefer. And once this is done, it returns the result, let's say in this case a number of JavaScripts, back to the AJAX call. And the AJAX call is waiting and waiting. You see that ready state only if ready state equals 4. So if the call was a success, it goes on. And if that is the case, it executes the result with the eval function. So basically, that is dynamic JavaScript, which is injected in this page. So with version 6, we have one new feature, which allows us to be even more performant. This feature is bulk loading, and that allows us to make up an array. So now, with this version, with this implementation that I have here, whenever I click something and I now pen or move the map, I execute this AJAX call, And here we see the first information popping up. This is low bridge information that we see here. Yeah, and I can add other information as well. So I can add, for instance, petrol stations, and they pop up here on the map now. Or I can add some railway stations. And everything is coming directly from the map. And whenever I move the map, it retrieves more information. But only those which are in the current map view. Everything else is, remains in the database. So I have 10,000 low bridges, and only one is now shown on the map. Yeah? So that reduces already the amount of data that I have to show and load a lot. But nevertheless, in this example here, I just add one shape after another. So for each shape that I want to add, I have to execute one JavaScript function, which means I'm not only limited by the space, but also by the performance. If I have more than 500 points, it becomes a little bit slow. But with version 6, we introduced this bulk loading, which allows us to add an array of locations with just one JavaScript call. And thus, I'm at least by factor 10 faster than before. So in the meantime, I've seen applications which show 10,000 points at a time in virtual Earth, and particularly if you consider that you want to do something with 3D models, or if you want to do something with GPX files, if you trace something, then it is a lot of points, and performance is crucial, of course. All right. But this is not all the content we can add. We have a lot of other methods and functions as well. We have the ability to add our own imagery. So we have a tool which is now officially supported, that is the Map Cruncher. And this Map Cruncher allows us to create tile layers in a similar structure as we have it in virtual Earth. So in this case, I want to overlay a floor plan on top of virtual Earth. So just zoom in a little bit closer, and you see here, I'm so close that I don't even see the virtual Earth tiles anymore. We don't have it at that zoom level, but I can see the desk where I'm usually working, yeah, right here. And this is overlaid directly on top of VE with the Map Cruncher. In this case, the tiles are stored again on Amazon, but that can be on any of your servers. It is not shared with anyone else unless you make it available through your application. Okay, so the tile layers, that was this. We can make that whole thing more dynamic. The tile layer basically determines the name of the virtual Earth tile and searches for a tile with the corresponding name. In this case, the Map Cruncher that I use, the tool which is now supported, creates the names automatically. But I can pull in a middleware in between, and I have described that in a white paper, which allows us to overlay even information from other servers. So in this case here, for instance, I will go now to Bavaria, or let's say to a city in Germany, my web map services. And in this case, I go to Borken. And you see we don't have aerial images here, but the city of Borken does. And I just contact their server and overlay the information now on virtual Earth. That is Web Map Service, a way to share geo information, image information over the web. So that can be done with different information. Unfortunately, I'm running out of time. So I'm coming to a couple of high-end integrations. This is the BP Hurricane management that I mentioned before. So you see that we have here all kinds of information integrated into a SharePoint site and available for analyzing. In that case, we plot the course of a hurricane, and we determine which of the facilities which belong to BP, platforms, offices, and so on, are within this course of the hurricane at which phase. In the back end, there is, of course, SQL Server, and there is BizTalk, so that we can immediately start the evacuation of these facilities. Well, coming soon is in early next year, Esri ArcGIS 9.3. And this Esri system is going to have a REST Web Service API. And what you see here is the integration between Virtual Earth and ArcGIS 9.3. So we render via a web map service this imagery information on top of Virtual Earth, but we can also do a callback from this image back to the ArcGIS server via the REST API and retrieve the meta information, in this case here, the utility information. So we will never, with Virtual Earth, compete directly with traditional GIS system. They need an accuracy which has to be higher than Virtual Earth. They need to edit their own data. Yeah? And if they dig out a gas pipe while they want to just fix a telephone line, then that is that is almost a disaster and very expensive, this mistake. Yeah? So they cannot afford to have inaccurate data. All right. So one last thing before I will be thrown off the stage. We have, of course, the SQL Server 2008 coming very soon. Well, very soon. It will be launched in February next year, but the launch event doesn't mean that it is released at that time. In fact, it will be released probably in July. And the SQL Server 2008 introduces two spatial data types, spatial indexing and 76 spatial functions directly in the database. So what I can do now with it is I can use Virtual Earth as a front end and do a lot of intelligent analysis functions in SQL Server 2008. So in that case, you see, I can draw, for instance, on the map in Virtual Earth. And once I have defined this feature, I can insert it into a database. And if I select it here, you see the SQL statement coming up, which is necessary to insert the data. We have, of course, direct loading functionalities. SafeFME is a great tool for that, and a lot of other tools we import from GML, and so on and so on. But we can also create it directly from VE. And to give you one example what is possible, let me pull up this simulation. So in that case, what we do is we have a ship which is sipping some oil or sinking and spills oil somewhere here in this region. And I draw my ship here now and start the simulation. And right now, every 5 seconds, the simulation will increase the radius of the oil sip, and it will insert these data into SQL Server 2008. In SQL Server 2008, I intersect the shape of this oil sip with the coastline. In this case, I'm using here data from the Esri world map, and I get here the area which is the first one to be affected. I calculate the centroid, and so on and so on. Well, these are just a few sample functions that we have. And unfortunately, I'm running out of time. But there's a lot to say. And if you have any questions, I'm here for the next 2 days. So you can visit us at the booth in the Ask the Expert area.